Okay, we're going to talk about something called Pythagorean identities. Okay, let's just go with a few basics real quick. What if we looked at, I don't know, cosecant of theta? Now, do we all remember that's the same as 1 over sine of theta? And I think you'd say, yeah, I know that. Then we talk about secant of theta, and we know that's really 1 over cosine of theta, right? And why don't we talk about cotan of theta? And we know that's really 1 over tan of theta. And that's not that bad, right? Why don't we look at something a little bit different, though? What if I had 1 over secant of theta? That means something, right? 1 over secant of theta might be better written as 1 over secant, and secant's 1 over cosine. And if I do a complex fraction, I now take this, and I flip it, and I multiply. So what I'd have is 1 over secant of theta is really going to be cosine of theta. And I could do that with any variation, right? And then I think, well, what if I had secant of theta over cotangent of theta? And said, could I write that differently? Well, yeah, you could. Secant is really defined, where am I? Right here, as 1 over cosine of theta. And cotangent's really defined as what? Cosine of theta over sine of theta, right? And then I could say, well, don't I really have sine of theta over cosine of theta? And that would result in sine of theta over cosine squared theta. And I just want to show you that because algebraically it all makes sense, right? Okay? So now let's look at a few other things. You get that idea right there. Okay? So why don't we look at this idea? What if I wrote down the Pythagorean theorem? A squared plus b squared equals c squared. Okay? Now you've done that a million times, and what that refers to is typically a right triangle, right? Well, let's look at this for a second. Why don't we let that be a, b, and c? A squared plus b squared equals c squared. Makes perfect sense, right? Now let's look at it, just a little bit differently. Why don't we look at this idea on a unit circle? Okay? And what I'm really trying to explain here is something called the Pythagorean identity. Okay? Why don't on the unit circle we let that be x? Right? That makes sense. Let that be y. And I could call that h for the hypotenuse, but on the unit circle, couldn't we always refer to that hypotenuse as 1 unit? Radius of 1? So let's do that. If I say x squared plus, actually, you know what, let me say y squared first. What if I said y squared plus x squared equals 1 squared? You guys are fine with that, right? But on the unit circle, don't we refer to this as cosine? Yeah. And we refer to this as sine, right? So could I say sine squared theta plus cosine squared theta is equal to 1 squared or 1? And if you can agree with that, what this is called is a Pythagorean identity, Pythagorean theorem, but this actually defines a lot of other math that we're going to get into. Okay? So that makes sense, right? So when I refer to the Pythagorean identity, this is what I mean. And let's do a few more variations of it. Okay? So here we go. Where am I now? Oh, there I am. Okay. So what if I write down sine squared theta? I'm going to say it all the time, so get used to it. Okay? I could have written that as x, like sine squared x, but theta is a nice thing. What these are going to be used for is almost like little puzzles. Think of them as a puzzle, like a nickname for something. So right now, let's come up with a new nickname. This is my kind of my king right here. Okay? Could I also refer to that algebraically as sine squared theta equals 1 minus cosine squared theta? I can do that, can't I? Could I also say cosine squared theta is equal to 1 minus sine squared theta? That's not crazy, is it? Does that kind of make sense? What if I said sine squared theta minus 1 is equal to negative cosine squared theta? Okay, and I'm going to pause so you kind of look at it here. Okay, does that make sense? And what if I said cosine squared theta minus 1 is equal to negative sine squared theta? That's a lot of variations on the same thing, isn't it? Okay. Kind of makes sense. So we could call that like option A, option B, option C, option D. Does that make sense? I think it does. So let's keep going with that idea. I'm going to rewrite this again. What if we said sine squared theta plus cosine squared theta equals 1? And I said, well, right now, why don't we just try dividing both sides by something? What if I divided both sides by sine squared theta? I'm allowed to do that, right? This is an equation. I'm doing the same thing to both sides. So if I divided that by sine squared theta, sine squared theta, sine squared theta, let's think what that means. Well, anything over itself is 1. Now I have 1 plus, well, cosine over sine. Well, sine over cosine is tangent, so cosine over sine must be cotangent. And I want to write that as cotangent squared theta equals. Well, now I have 1 over sine squared theta. Isn't 1 over sine mean something too? What's that? So 1 over sine is going to be cosecant squared theta. Okay, I'll pause again. Okay, so I got 1 over sine cosecant. Now I'm going to think, well, how can I rearrange that? Well, let's let that be E. Well, I have a lot of variations. Can I say 1 minus cosecant squared theta is equal to negative cotan squared theta? Yeah, I could do that, couldn't I? Could I say, why don't we let cosecant squared theta minus cotan squared theta is equal to 1? Okay? Could I say, I mean, it doesn't really, a whole bunch of different ways, right? Could I do, oh, I don't know. You get the idea. A, E, F, E, F, G, right? Makes sense? It really does, doesn't it? That's, math is great like that. Let's try another variation on that. What if I said sine squared theta, I told you you're going to hear it a lot, cosine squared theta is equal to 1, and this time, why don't we divide everything by cosine? Well, we can do that. Well, technically cosine squared theta, right? Now this time, let's think. What's sine over cosine? Well, I think that's tangent, right? So now I have a tangent squared theta plus 1 is equal to what? Is that secant squared theta? Let's take a second to reflect on how wonderful this is. E, F, G, let's call that H. Okay? Does that make sense? Okay, let's think about it again. Now if I have that, can I rewrite that a few different ways? Yeah, H, I'm not good with my letters. H, I, J. Okay, here we go. So why don't I say we got tan squared theta, and I'm going to minus secant squared theta, I'm going to equal that to negative 1. Does that make sense? Well, what if I have 1, and I want to say, is that secant squared theta minus tan squared theta? Am I allowed to do that? I think I am. I think you're getting the idea. So basically what I'm saying is we're going to rearrange a bunch of stuff and be able to do problems, trigonometric identity problems. But if you can rearrange stuff like this, kind of on demand, and again, any variation of that, then you're doing well, okay? But you got to be able to move stuff around like that. Okay? Good job. Bye-bye.